So we're now talking about series. This is a result of adding the terms of a sequence. So if you take all the different terms that are created and you add them up, you create a series. And we use this notation. It's called sigma notation or summation notation. And so what it means is this is where we start, right here. And this is where we end. And we use every single term from there to there. So here we're going to plug in 1, and then 2, and then 3, and then 4, all the way to 5. So we're going to start at 1, end at 5. So we start with 1, and we plugged it in for n. We plug 2 in for n, 3 in for n, 4 in for n, and 5 in for n. And then you add them all up. That's what this sigma notation means. So we end up with this, which is 60. And you can also do this into our calculator. So if you hit math, and you can either scroll up, and you'll see summation, so scroll to that. Or you can just hit 0 and it brings up our sigma notation. So you just need a variable, so we can use x or whatever letter you have here. And we're going from 1 to 5, and then you enter the general term. So n squared plus 1, and you hit enter, and there you go, it's 60. So you can check every single answer using your calculator. So let's try a few. So here we're plugging in 3 for our j, and then 4, and then we stop at 5. So this would be 1 over 3, and then you put plus, 1 over 4, and then plus, and then 1 over 5. And then that equals 47 out of 60. And then we check with our calculator. You can see it is 47 out of 60. By the way, when you finish these, you know it's going to come out as a fraction. So if you hit math, fraction, enter, it'll give it to us as a fraction and not the decimal. All right, so 47 out of 60. Let's try another one. So here you can see now this is our alternating one that we had before. And so when we plug in our 1, it's going to go here, and then the 2 will go here and here. So we're replacing the i's with our variable. All right, and then so the next would be parentheses. You always want to place them in parentheses. 1, and then square like that, plus, and then we do it again. So negative 1, parenthesis, parenthesis squared. So you can write everything but the I, and then come back and place it in. So that would now be 2 for the exponent and 2, and then 3 for the exponent and 3, and then that's it. So what do we get? We get negative 1 times 1 plus positive 1 times 4 plus negative 1 times 9. So putting that together, we get negative 1 plus 4 minus 9, and there's our alternating. So this would give us negative 6. And checking in our calculator, negative 6. All right, one more. I want you to try this one now. So I just want you to plug in 1 to 4 through this, and then verify in your calculator it is correct. Hit pause now. So plugging it in, we get this. And if you simplify it, you'll start to see the pattern that's forming, because this is a nice general term. Just like up here, we're getting our perfect squares. See, it's a perfect square. And here you can see it's n and then the one right after it. So it's 1 times 2, and then 2 times 3, and 3 times 4, and 4 times 5. So the next would be 5 times 6. And so you could, if you wanted to, after you figure it out, you would just know what the next one would be. But we don't have to do the next term. But we get negative 11 over 30. We check our calculator, and everything checks perfectly. So there you go. That's our sigma notation. Thank you.